Bismillahirrahmanirrahim. With the name of Allah, who is very kind and merciful. Welcome to KingCambridgeSolution.com. On this website, you will find the solution of Cambridge International AS and A level and O level. Today, I shall explain some question of Mathematics 9709, paper 4, part variant 2. The session is October-November 2024 and the paper is paper 4, Mechanics. The question number 1 is, the velocity of a particle moving in a straight line at a time t second after leaving a fixed point O is v meter per second. The diagram shows the velocity time graph which models the motion of the particle from t equal to 0 to t equal to t. The graph consists of 4 straight line segments. The particle accelerates from rest to a speed of v meter per second over a period of 4 seconds. And then deaccelerate at 5/3 meter per second squared to instantaneous rest over a period of 6 seconds. The particle when travel back towards 0 O, the reaching a maximum speed of 3 meter per second before coming to the rest at a time t. Part A, find the value of v, and the part B is given that the total distance traveled by the particle from t equal to 0 to t equal to t is 68 meter. Find the value of t. Now we shall check the solution for part A. The solution for part A is from the graph we know that in order to calculate the deceleration or acceleration, the formula is change in velocity over change in time. Change in velocity over change in time. Change in velocity means the final velocity minus initial velocity over change in time, the final time over initial time. So in this case, the deceleration is given as you can see that is 5.5/3 meter per second. So minus 5/3 minus is due to the deceleration, and the velocity if you can see that velocity is from 0 to v2. So v2 minus v minus 0. After that, initial velocity or final velocity 0 minus v over the other one is change in time. Change in time means for the deceleration, change in time is 10 minus 4. Change in time is, this is the deceleration from 4 to 10. So the time is 10 minus 4. This is 10 minus 4. So after simplification, we get v equal to 10. So the velocity of the time, velocity is equal to 10 meter per second. For the part B is given that the total distance traveled by the particle from t equal to 0 to t equal to t is 68 meter. Find the value of t. Now we shall explain the solution of part B. In part B, you can see that we have two triangles. One is the OAB and other is BCD. BCD is the backward motion of the particle. So we know that in order to calculate the area under the curve, we have formula for the triangle. From the graph, the total distance is equal to area under the curve OAB plus area under the curve BCD. Area of triangle OAB and area of triangle BCD. We know that in order to calculate the area of the triangle, we formula is 1/2 base into height. 1/2 base into height. In the first case, the base is equal to, in the first triangle, base is equal to 10 minus 0, and the other is t minus 10. For the second triangle, base is equal to t minus 10. So this is the t minus 10. By putting the value of v, because v as we have calculated in part A of this question, v is equal to 10. By putting the value of t and after simplification, we get t equal to 22 seconds. The value of t is equal to 22 seconds, which is required. So for question number 2, a block of mass 20 kg is held at rest at the top of the plane inclined and 30 to the horizontal. The block is projected with speed 5 meter per second down the line of greatest slope of the plane. There is a resistance force acting on the block. As the block moves 2 meters down the plane from its point of projection, then work done against the resistance force is 50 joule. Find the speed of the block when it has moved 2 meters down the plane. The question number 3 is, a cyclist is riding along the straight horizontal road. The total mass of the cyclist and his bicycle is 90 kg. The power exerted by the cyclist is 250 watt at an instance when the cyclist's speed is 5 meters per second. His acceleration is 0.1 meter per second square. Part A, find the value of the constant resistance to motion acting on the cyclist. The other one is, the cyclist comes to the bottom of the hill incline and 2 degrees to the horizontal. Part B, given that the power and resistance to the motion are unchanged, find the steady speed which the cyclist could maintain when riding up the hill. The question number 4 is, the diagram shows two particles A and B of mass 0.2 kg and 0.1 kg respectively. The particles suspended below the horizontal ceiling by two strings AP and BQ attached to the fixed point P and Q on the ceiling. The particles are connected by a horizontal string AP. Angle APQ equal to 45 degree and BQ P is equal to theta degree. Each string is light and extensible. The particles are in equilibrium. Part A, find the value of the tension in the straight line AB. Part B is find the value of theta and tension in the string BQ. Question number 5 is, two particles P and Q are mass 2 m kg and m kg respectively are held at rest in the small vertical line. The height of P and Q above the horizontal ground are 1 meter and 2 meter respectively. P is projected vertically upward with a speed of 2 meter per second square at the same instance Q is released from rest. Part A, find the speed of each particle immediately before the collide. Part B is, it is given that immediately after the collision, the downward speed of Q is equal to 3.5 meter per second. Find the speed of P at the instance it is reached the ground. The next question 6 is, a particle P travels in a straight line starting from a point O with the velocity 6 meter per second. The acceleration of the particle P at time t is acceleration of P at time t second after leaving O is meter per second square, where A is equal to minus 1.5 t raised by 1 by 2 for 0 less than t less than 1. And the next acceleration is 1.5 t raised by 1 by 2 minus 3 t raised by minus 1 by 2 for t greater than 1. Part A, find the velocity of the P at t equal to 1. Part B is, given that there is no change in the velocity of the particle when t equal to 1. Find expression for the velocity of P for t greater than 0. The next C is, given that the velocity of P is positive for t less than equal to 4, find the total distance traveled between t equal to 0 and t equal to 4. The last question, question number 7 is, two particles A and B of mass 0.2 kg and 0.3 kg respectively are attached to the ends of a light and an extensible string. The string passes over a small fixed smooth pulley which is attached to a bottom of the rough plane inclined at an angle of theta to the horizontal, where sin theta equal to 0.6. The particle A lies on the plane and the particle B hangs vertically below the pulley 0.25 above the horizontal ground as shown in the diagram. The coefficient of friction between A and the plane is 1.125. Particle A is released from rest. The part A is, find the tension in the string and the magnitude of the acceleration of the particle. The part B is, when B reaches the ground, it comes to the rest. Find the total distance that A travels down the plane from when it is released until it comes to rest. You may assume that it does not reach the pulley. So, how to access the solution of the remaining question? In order to access the solution of all the question, first step is open the website. The URL is kingcamrysolution.com. After that, the first step is you will click on the right more top corner, login and register. When you click on this link, you will find this interface. Providing the, after that you will click on the sign up. When you click on the sign up, you will get another interface like this one. Provide the username and password and email address and click the sign up. You will log in automatically, or you can also log in manually by providing your user and password this in the form. So after login, when you log in, then come to the courses link of the website and click the course list. When you click on the course list, then you see the different courses on the website. When you click the courses you need, you will get this interface. First of all, you will click the button add to the cart. The course will be added to your cart. After that, you will click on the buy now. When you click on the buy now, then you will find the interface for the stripe. Fill the stripe according to your fields, and after that, when you click on the submit button, the course will be come to visible in your order history. Your order history will become here. When you click on the combo box, there is a link order history. When you click on the order history, you will find the course that you have purchased, this course. When you click on this course, you will see the in the content section, you will see two icons. One is the file icon and other is the video icon. When you click on the file icon, a PDF file will be downloaded about the solution of the question 1. And when you click on the video icon, the video file of that question will be downloaded with the solution. Wish you good luck. See you in the next session of the exam.